to the 5-minute binary lesson. So first little task, little knowledge review. So I want you to pause the video, have a look at the code and see if you can answer the videos. Okay, we're back on here. So the data type used is in this code. So it's superhero, so that's a string. The line number where you see a variable can be line number 1 or 3. Line number for selection is 528. Make sure you get that right. Line number for an output can be 6 or 8. And the operator is an OR, which is on line 5. So what's binary? So binary is or machine code. So it's a set of ones and zeros, which represents 1 being on and 0 being off. Binary is used to represent data, programs, instructions within the computer system. Obviously, the computer has a CPU, which has billions of transistors within it. Transistors are a little switch, which has an on and off feature, and obviously that's how it represents binary. So this is base 10. So base 10 is a number system which you're familiar with, which you work in maths. So it has obviously 0 to 9. This is what you use all the time. So we have the number 6,133. So we have 6 1,000s, 1 100, 3 10s, and 3 1s. So your hundreds, tens, and thousands units. So this is what we're familiar with. However, binary is in base 2. So base 2 has ones and zeros. So there's only 2 numbers. This is 8 bits. So it's 8 digits. 1 bit is 1, and we read from left to right, and you can see we have our place values, which are a denary alternative. So this is our denary numbers, which is 1, 2, 4, 8, and doubles each time. So to convert binary to denary, the first thing we have, so if we had a number, let's say if we had a 0, 0, 0, 1, 0, 1, 0, 1. What we do here at this point is we count the ones. So where there is a 1, we add it up. So we'll have 16 plus 4 plus 1. So the answer to this question would be 21. So 0, 0, 0, 1, 0, 1, 0, 1 would be 21 in binary. So that's how we convert. So remember, to convert, you have to get your place values at the top, which are these in denary. Where there's a 1, we count the 1 and add the numbers up. So for the next one, so if we need to convert the other way, so denary to binary. So to convert denary to binary, if we had a number in here, let's say we had 30, let's say 34. So what we do is say, is 34 greater than 128? Nope, so it's 0. Greater than 164? Nope, 0. Greater than 32? Yes, it is. So we'll put a 1 in there, then we minus 32 off, which would leave us with the value of 2. And again, it's 2 greater than 16? No, no, no. Yes, it is. Minus the 2 off, leaves us a 0 remainder. So 34 in binary is 0, 0, 1, 0, 0, 0, 1, 0. So you can see what we do is we get the number and we minus it out until we get the correct binary digit. So the combination of bits, so bits within binary can represent colors, letters, numbers, sounds. So if I have 2 bits, it means there are 4 combinations here. So we have 4 combinations. I want you to now pause the video and see if you can figure out the next 2. Okay, so we can see here for 4 bits, we'd have 16 pieces of combinations. For 8 bits, we'd have 256 pieces of data, which we can use within binary. So what I'd like you to do now is pause the video again. I'd like you to complete this revision sheet with keynotes for binary. Okay, you should have completed your revision sheet. And now what we're looking at is the answers to the questions at the bottom are there. So now these are additional links which you can click on. They're in the resource at the bottom for some additional reading. Okay, we're going to have a go at an exam style question. Now we've done our notes and looked at it. So this is our exam question. So have a read of this, pause the video and see if you can attempt the question. Okay, so what we're going to do now is have a look how to answer this question. So the first thing we need to do, because we need to convert 60 into binary, so we're going to do our placeholders. So 128, 64, 32, 16, 8, 4, 2, and 1. And we get 60, and we know 60 is less than 128, so 0, 60 is less than 0. We know it's that, so it's a 1. And what's left over? So we have 28 left over, so 28 into there, yeah, that's fine. 0, 0, 1, 0. So this number here is the correct answer. We'll get 2 marks first mark if you get the first half right, and the second mark for the second half right. The next one is to convert this to denary, so the same again, 1, 2, 4, 8, 16, 32. So we've got 32 plus 2 plus 1, yeah, equals 35. So the answer to that question is 35. Okay. So last thing for the end of this lesson, if you go to this URL, it's a little binary game which will really shore up your knowledge from the introductory binary. So thanks for watching the 5-minute lesson. Hope it's helped. Thank you and bye.